You probably do this dozens, maybe even hundreds of times a day. You see an app, you click on it, and poof, it just opens. It feels instantaneous, almost like magic, right? But what's actually happening inside your computer when you do that? Yeah, have you ever really stopped to think about it? That tiny sliver of time between your click and the app popping up on screen. What is going on in there? Well, that's what we're going to break down. Let's follow that click and see where it takes us. Okay, first up, the click that starts it. It all kicks off with that one simple action from you. Think of it like firing the starting pistol for this incredibly fast race that's happening completely out of sight. So, the second you click, you're not actually talking to the app itself. Nope, your click is a direct command to the big boss, the master controller of your whole computer, the operating system. You're basically pointing and saying, hey, you, load this program for me now. And what is that program file you just clicked on? You know, the .exe file or the application icon? At its core, it's just a really, really long list of instructions. But it's written in a special language called machine code. This isn't a language for humans, like Python or Java. No, this is the native tongue of the computer's brain, the CPU. It's literally the only thing it can understand. All right, so the OS has the command. But here's the thing. The program can't run from where it lives permanently. Before the CPU can do anything, that program has to take a trip. It has to move from its long-term home into a temporary, super fast workspace. And this move is absolutely critical. Here's the best way to think about it. Your storage drive, your SSD or hard drive, that's like a giant library. It can hold tons of books, all your programs and files, but finding a specific sentence and bringing it back takes time. RAM, though, RAM is the workbench right in front of you. It's much smaller, but whatever you put on it, you can grab instantly. So the OS has to act like a librarian's assistant, grabbing the right book, your program, from the library and slapping it down on the workbench so the real work can begin. Okay, the program is now on the RAM workbench. And now, the star of the show finally enters the scene. The CPU, the central processing unit, takes over. This is the brain, the one that's going to do all the thinking. So what does this brain actually do? It just runs a super simple loop, but it does it at a truly insane speed. First, it grabs one instruction from RAM. Then, it decodes it, figures out what it's being told to do. After that, it executes it, does the calculation, moves a piece of data, whatever it is. And then, it does it again, and again, and again. Millions or even billions of times every single second. It's almost impossible to wrap your head around that speed. But here's a really important thing to realize. The program isn't some lone genius working in a vacuum. Not at all. It can't really do much on its own. If it wants to do anything useful, like actually draw a window on your screen or connect to Wi-Fi, it has to ask for help. And who does it ask for help? You guessed it. It goes right back to the manager, the operating system. The program is constantly sending out little requests. They're called system calls. It's basically saying, hey OS, I need you to draw a button here, and the OS tells the graphics hardware to do it. Or hey, I need to save this document, and the OS handles the storage drive. It's this constant back and forth. The program asks, and the OS coordinates all the other parts of the computer to make it happen. And this manager role is also super important for safety and stability. The OS acts like a strict traffic cop. It puts each program in its own little bubble, its own sandbox, and manages its permissions. This is what stops your web browser from snooping around in your personal files, or keeps one buggy game from crashing your entire computer. That management is what keeps the whole system from descending into chaos. So we've had all this frantic, behind-the-scenes action going on, but what's the payoff? What's the end result that you, the user, finally get to see? Well, all those billions of instructions the CPU has been chewing through, they all lead to this. The CPU teams up with the GPU, which you can think of as the computer's dedicated artist, and together they paint the final picture. They create the actual image of the window, the buttons, the text, everything. They send that final visual to your screen, and bam, there it is. Your program is up and running. So you can see it's never just one thing. Running a program is this incredible high-speed digital ballet. It's a perfectly coordinated team effort where every single part of your computer has a critical role to play. So let's just quickly recap the players on our team. You've got the operating system, that's the manager, calling the shots. You've got the CPU, the brain, doing all the thinking. There's the RAM, the fast workspace right in front of the brain. You have the GPU, the team's artist, making everything look good. And it all starts in storage, the huge library where everything is kept. Every single one of them has to do their job perfectly for that magic to happen.
Right. So we've got the program open. But what about when you're finished? What happens when you hit that little X to close it? The process has to run in reverse, and the cleanup is just as important as the setup.
When you close an app, the OS manager steps back in. It tells the CPU, okay, you can stop working on that now. And most importantly, it erases the program from that valuable RAM workbench. It cleans up the space, putting everything back where it belongs. So all those resources are free and ready for the next program you decide to launch. A tidy workspace is a happy workspace, right?
So, we follow the whole journey. We know a program is just a list of instructions, and we know there's a whole team of components that work together to run it. But that still leaves one huge, mind-bending question. How does that little piece of silicon, the CPU, actually do it? How does it read those instructions? How does it turn simple electricity into complex logic? Now that is a story for another time.